students, in this lecture we will going to discuss magnetic properties of lanthanide element. So dear students, you know that what it means by magnetic moment. Every electron will act as a tiny magnet because of its spin of electrons around itself and around the orbitals. So this magnetic moment are calculated by using the mathematical formula. Mu is equal to Z into root of J into J plus 1. So here Z is Land's constant, or we can say it is a gyromagnetic ratio. J is the resultant angular momentum quantum number. First of all, let's see what is Z, or the Land's constant, how it is calculated. So its formula is 1 plus J into J plus 1 plus S into S plus 1 minus L into L minus L plus 1 divided by 2J into J plus 1. Okay, so this is the formula to calculate the Land's constant. Now the next one, what it means by J. So this J is equal to two values, either L plus S and J is equal to L minus S. So both these values. So dear students, we have to see what it means by L plus S. When some cell is half full or more than half full, with L minus S is for when some cells is less than half full. Dear students, we have to see in these lectures how to calculate the magnetic moment of inner transition elements. Okay. So dear students, today in this video we are going to see how to calculate the magnetic moment of inner transition elements. Okay. So for inner transitions, for calculating the magnetic moment of inner transition elements. So here we will take the example. For example, here I will take cerium 3 plus ion, that is lanthanide. Okay. For calculating the magnetic moment of inner transitions element, we have the mathematical formula mu, which is equal to Z into root of J into J plus 1. So by using this formula we can calculate the magnetic moment. So this is G is gyromagnetic ratio, or we can say a Landage constant, which is given by G, which is equal to J into J plus 1 plus S into S plus 1 minus L into L plus 1 whole divided by 2J into J plus 1. So what is J, dear students? So this J is called as resultant quantum numbers. So what is the resultant quantum number? Which is either given by the values of L minus S or L plus S. So what is L minus S? When subcells are less than half full. Less than half full. And when we have to take this L plus S, when subcell is half full or more than half full. Okay, then you have to take a L plus S. So here we have to calculate the magnetic moment of Cerium. Okay, so first it's very important to know the valence cell in which the unpaired electrons is present. For that we must know the electronic configurations of Cerium. So dear students, here first of all we have to see the electronic configuration. We have to see the electronic configuration of Cerium 3+ ion. So you know that atomic number of Cerium is 58, right? So here atomic number of Cerium is 58. So electronic configurations, you know that then Cerium having electronic configurations, that is xenon 54, then 4F, then 5D and 6S. These are the valence shell for Cerium. So you know that in 5 that is 54, so 1 electron D and 2 electrons in S2. So this is electronic configuration of Cerium. But we have the Cerium is in +3 oxidation state, right? Here we are observing +3 oxidation state. So in +3 oxidation state, Cerium +3 oxidation state, its electronic configurations is likewise. So you have this xenon 54. So what it means by +3? It loses 3 electrons from the valence shell. Okay, so this is a 6 and 5D are the valence, and these 5D and 6s electrons are lost. These 3 electrons are lost by Cerium and results into the 3+ ion. So its electronic configurations will be 4F1, 5D0 and 6S0. So dear students, this D subcell D 5D and 6S loses the electrons and Cerium becomes +3 ions. Okay, now we know that Cerium has only 1 unpaired electrons in its valence shell, that is in 4F subcell. So this 4F having only 1 electrons, and due to this 1 electron, this Cerium shows a magnetic moment. So dear students, we can calculate by using the formula mu is equal to Z into root of j into j plus 1. So first we must know the value of z, and later on we will find out the value of j. So first we must know the value of z. So z, which is equal to, what is the formula? J into j plus 1 plus s into s plus 1 minus L into L plus 1 divided by 2j into j plus 1. So dear students, now as we have to calculate the value of j, that is either its value is L minus s and L plus s. So dear students, let's see this F subcell. I will try to draw here this F subcell, that is 4F. We know that this 4F subcell have how many orbitals? 7 orbitals. 1, 2, 3, 4, 5, 6 and 7. So these are the 7 orbitals, right, for F subcell. So this is a 3 plus 2 plus 1, 0, minus 1, minus 2 and minus 3. What are these? These are the azimuthal quantum numbers, that is a small l, right? And this capital L is the total magnetic moment, that is summation of small l. What is means by this capital L? That is the summations of small l. So dear students, whenever we have, as this cerium have only 1 electrons, right? So due to this 1 electron, this cerium shows a magnetic moment. So this is only 1 electron which is responsible. For that, L value will be is equal to, what is the L value for this electron is, yes, you are observing, that is a plus 3. So dear students, therefore L is equal to, you will get 3. So here the problem, now we have to calculate the S. So what is S? S is equal to total spin of electron. So how to calculate the total spin of electron? That is number of unpaired electron divided by 2, which is equal to how many number of electron? Only 1 divided by 2. Therefore S, that is a total spin of the electron, is 1 by 2. So you got the value of L and S. Now we have to calculate the value of J. So their values are 2. Either one is L minus S and another one is L plus S. So which value we have to take? So see carefully, when the subcell is less than half full, okay, then we have to take L minus S. So see there students, 4F is having 7 orbitals and these 7 orbitals have only 1 electron. So all other are empty orbitals. Okay, so means it is a less than half full. Half means this orbital is having the capacity of 2 electrons, but here it has only 1 electron. So one electrons when we fill up on these 7 orbitals, then it becomes a half full, right? So it is a less than half fill now, as it has only 1 electron. Hence, which value we are going to take then? we have to take L minus S, not L plus S. Okay, so hence we are taking here the value L minus S. So what is the value of L? Is 3. What is the value of S? That is minus 1 by 2. So when we find out its value, so it becomes your 5 by 2. Okay, so dear students, therefore we get the value of J, which is equal to 5 by 2. Okay, so this is your value of J, that is 5 by 2. Now after moving the value of L, S and J, we have to simply put these values into the Lagrange constant that we have to calculate. So for J we have the value 5 by 2, right, into 5 by 2 plus 1 plus what is the value of S? Is we have 1 by 2 into 1 by 2 plus 1 minus what is the value of L? 3 into 3 plus 1 divided by 2 into what is the value of J? That is 5 by 2 into 5 by 2 plus 1. So here 1 is remain to add. Now we have to simply this one later on we have to add, that is remain as it is. First of all we have to solve this whole square bracket, right? So 1 plus, so after we have to solve this bracket first of all. Okay, so we will get very simple, that is 5 by 2 as it is. If we solve this first bracket, then we got it is 7 by 2 plus 1 by 2 into 3 by 2 minus what is 3 into 3 plus 1 4 and 4 into 3, that is your 12 divided by whole divided by, so 2 to get cancelled, and here 5 into what do you have, that is 7 by 2, right, when we simplified it. Now in the next we have to very simply simplify this, solve this. After solving we get the value, that is see here 35 by 4 plus 3 by 4, right, minus this will you get near about 17.5. Okay, so after simplifying this, in short you will get 1 plus into bracket 8.75 plus what is this value, 0.75 minus 12 as it is divided by 17.5, which is equal to 1 plus 9.5. Okay, when we add this, minus 12 divided by 17.5. So if we simplified it once again, 1 plus into value minus 2.5 divided by 17.5, which is equal to 1 plus, when we divide it, so its value minus sign as it is remain. When we divide 2.5 divided by 17.5, we got near about 0.14. We get near about 0.14. So 1 minus 0.14, we get near about 0.86. So dear students, we get the value of Z, that is 0.86. Now we have to put the value of this G into the equations here. So what we obtain, our Z value is 0.86. Okay, so very simply we have to put this value of G there, that is 0.86. Now into, we have to put the value of J. What is the value of J? Root of 5 by 2 into 5 by 2 plus 1, right? So which is equal to 0.86. So we already simplified it earlier, right? And its value we get 8.75. Now we have to take the square root of 8.75. So the square root of 8.75 is near about 2.958, and when we multiply the 0.86 into 2.958, we get the value 2.54 bm, that is Bohr magneton, and this is your magnetic. Therefore the magnetic moment